Hello all. We are at the end of the semester of this course, CS47. We had a very interesting journey throughout, at least from my side. Um, let's recap what we have learned in this course in a nutshell. Number one, we have started with this thing, right? Someone is in vain shouting towards a robot Wally with some very high level programming language and not getting response on that because it simply don't understand that language, which probably in case of Wally it is not the case, but in general, like computing system does not understand that language, though we as a human perfectly understand this language. At least we know what this piece of code is trying to do there. But then in place what we have seen that there are these other tools like compiler and assembler which basically picks up this high level program and generate a much lower level assembler program, and then assembler takes that assembly program into the program machine code and which the machine understand. Now both parties are happy that we write in program in a high level language get translated into the machine code which machine understand. So essentially what we learned through in this course is how to communicate with a computer, right? So it is not really the one, maybe the perspective you had till this course that, well, you write in Python, write in Java, write in C, C++, and computer just pick it up. It's not the case. It's basically it need to get translated and transformed into a language that machine can understand. So that's the nutshell what we learned. And on top of that, what we have seen, let's say I have a laptop or a machine or desktop or anything, and internal looks like very cryptic, like this, like we don't know anything about hairs and tail, but somewhat we can actually manage to have a simplified model of computing, hardware model of computing through like register file. We somewhat understand what it is. We understand ALU, especially how the arithmetics, integer arithmetics is done inside the ALU. We have somewhat more like conceptual level gaze at the control unit and the memory at that point, the logical model of the memory. Through this, what we have done in this study, especially after the midterm, is the components of a computing system. It's more like a computer organization, and what is the role of each of this component in computing, basically the program you're writing, how it is get executed through all these. And this is a journey what we have started in this course CS47, and then we'll continue that journey on to the next course CS147, which is computer architecture, and we'll basically learn more detail about this register file construction, ALU construction, control unit construction. In fact, in that course, we will build up a tiny processor from bottom up, like putting together all these basic components. And that tiny computing system, actually you'll see we can actually run like real life algorithm like Fibonacci generation or something like reverse Fibonacci generation or any sort of like mathematical program that you can come up with, you can run with that computer that will build up in 147. So we have learned so far like very elementary level number systems, instruction representation, digital design. We know how to swim across this world and keep ourselves alive. We know in the horizon there are something like computer architecture, operating system software. Those courses are on horizon. We need to need to go and explore those material. And somewhat we did a little bit dive down. We just at the snorkeling level, I would say. It's not a even inside a deep diving kind of scenario. It's just a snorkeling scenario for the computer organization and assembly programming. We just scratched the surface little bit, maybe dive down maybe 10 feet, maybe 12 feet under the water. There are more basically. So question is where to go from here. As I was indicating, dive down and explore, right? We have quite a lot of different courses you can explore to quench your thirst for curiosity around this computing system. Couple of them, definitely one of them is 147 that you guys need to pick up anyway, because this is mandatory for the computer science students. You can pick up computer architecture, advanced computer architecture 247 in that line. These are all hardware related. Like you can, if you are interested in taking like external department subject, I would suggest computer engineering 240, which is computer design. So we did in this course and we'll do in the 147 mostly processor oriented things, and will be some sort of memory interaction and memory oriented. But this 240, course 240 deals with like how you build up a computer system, like with all this display, keyboard, mouse, how they're integrated together to build a usable system, right? It's not a bare minimum processor and memory anymore. It's how you assemble together all these subsystem to make a complete computing system. So that's a very interesting subject. If you are interested in the digital design, E272 is another course you probably is interested in. So what we did and what we'll be doing in CS147 is explore that part of the digital design which is relevant for computer architecture and computer system design. There are tons of more things about digital design. For example, your soda vending machine, right? That's a little bit of controller, a little bit of how it exchange coins and notes and etc. The denominations, stuff like that, how the denomination is computed. Those things does not have full-scale processor. They're very targeted application digital circuit, and how to design those things. And there are tons and tons of different application of digital design apart from deploying a specific processor for a specific problem. Of course, like any digital problem, if you have a processor, you can solve it. But point is it like a price worthy or not? Because processor are not cheap component. It's not cheap at all. But if it is a simpler enough like a vending machine, you don't need to deploy a full processor. It's basically just target design for that specific problem and get it done. So that kind of things is done in the E272. Now, as a computer science student, I would recommend you to go with the parallel processing 159. That's a very relevant in this current market. Definitely operating system is, I think, one of the mandatory course that you need to go through. That will actually will give you more insight onto how a system works and how that software to hardware interaction happens at that level. So this is very important. And also remember, we had this conversion problem of high level to machine code. We just assume in this course there are these things, compiler, assembler available. We kind of discuss a little bit on the assembler side, but main challenge is the compiler design. I think this course is now called language studies, something like that. But essentially, this technology is very essential in our computer world, that we as a human try to go and code in a language which we understand fluently, and which is like human graspable but may not be machine graspable. But how to transform that high level description into low level machine level description with the intention of the program unaltered. Okay, so that's the whole problem of compiler tool design. Like you take a language, how you change it to another language without changing its inner meaning, and that's the very, very fascinating and interesting subject, I would say. And as a computer science student, you should explore that area as well. And on top of that, definitely the operating system. Natural path is advanced operating system. If you are interested in that, and I hope you would pick up that area as a computer science professional. So that's all I wanted to say, and thank you very much for attending my course. I hope I was able to give you some insight into the computing system. I wish you good luck in your future and your final exam, of course, coming up. I hope you'll all do great overall in this semester. I hope you did enjoy my course, and I hope to see you, most of you, on my CS147 course. Thank you very much.